Hi, and welcome to my channel. My name is Jack. In this video we're going to talk about the building of a lighting sequencer. And I'm going to show you how to build a high-density, low-cost model railroad lighting sequencer using the 555 timer. The first video will talk about the 555 timer, which is the basis for the sequencer. The second video will talk about the details and how to construct one and what its uses are. Okay, let's get started. Okay, let's talk about a model railroad light sequencer. Well, what is a light sequencer in model railroading? Well, sometimes it's called by a different name. Sometimes they're called rig counters. Sometimes they're called shift registers in electronics. Sometimes they're called waterfall displays. Basically, they're a method of lighting up LEDs in a particular way. In our case, it's going to be a random manner to light up buildings or parts of buildings, which LEDs will go on and off. So before we get started on the actual implementation of the light sequencer, we need to talk about some basics. One of the first things we're going to talk about is the 555 timer, which is going to be the basis of the light sequencer. The 555 timer has two basic modes. The first one is a monostable mode, sometimes called a one-shot. That means you put out one output pulse when the timer is triggered, and it must be re-triggered for each output pulse. The next mode is Astable. It's basically an oscillator, free running, and it keeps outputting pulses automatically once it starts. Okay, this is the configuration for the 5.5 timer in monostable mode. You can use the formula right here, which will calculate the value for the output pulse duration, but I prefer to use an online calculator for the 5.5 timer, and I'll put a note and a link in the description of where you can find those. There's several available and they're pretty good. All you do is you choose the configuration you want, whether you want monostable or astable. In this case, it's monostable. You have one resistor and one capacitor to worry about. So you type in here the 200, in this case, 240 k ohms. You can pull down to make it mega ohms or ohms. So just make sure you get the units right. And the capacitance value in this case is 10 microfarads. If you do that, it'll come out with a calculation that the output pulse duration is 2.6 seconds. And over here is a little graphic of what you can expect to get. When the input pulse goes low, the output pulse goes high for 2.6 seconds. And R2 is not critical. It could be 100K or whatever. It's just to provide a trigger pulse to the chip. Now, typically, the maximum time is roughly 1 minute to 1 minute and 10 seconds. But it can be longer depending on the specific 555 version, up to several minutes to 30 minutes or longer. It also can be extended to much longer times by using a counter or by using a modified circuit, which I'll also post a link in the description. Okay, so this is the Astable circuit for the 555 timer, and this is the one we're going to be focusing on for the actual sequencer itself. So once again, you choose the configuration, in this case Astable. You pick the resistor value for R1 and R2. In this case, you need two resistors, and you need a capacitor value to be inputted. And here, for example, it's 10 microfarads. So if you type in those three values, the calculator comes out with a high time of 1.9 milliseconds, a low time of 69.3 milliseconds, and a frequency of about a half a hertz. And over here again, there's a nice little graphic of the time that the pulse is low and the time that the pulse is high. So here's another tool to use for determining the frequency of the 555 timer. This is a graph that's in most data sheets on the timer. And what it allows you to do is show the frequency for various values of R1, R2, and C1. It's a little bit easier than plugging in the calculator and by trial and error. So in this case, you would have a RA and RB, which is the same as the R1 and R2 in the previous slide, means the same thing. And for example, if you pick an RA and plus 2 RB to equal 100K, then you follow this line down to the capacitance level or capacitance value you're putting into the circuit. So in this case, it's 1 microfarad right here. And the free running frequency along that line for RA and RB, 2RB, is 10 hertz. So the other thing you have to consider is the maximum and minimum frequencies. The typical maximum frequency, again, depends on the particular chip and manufacturer, but it's typically 500 kilohertz to 2 megahertz. The thing we're going to be concerned about more in the sequencer is the low frequency. And here you say the low frequency is about 0.1 hertz, which is about 10 seconds. So we want to extend that, and there's some techniques for doing that, and we'll talk about those in a minute too. If you need accurate timing, that is, a timing that agrees with the formulas, then you have to think about a few things. One of them is to review the minimum and maximum frequencies. Usually for most of the 555 family, the minimum and maximum frequencies are 0.1 hertz or 10 seconds to 2 megahertz. Also consider the capacitance tolerance. Some capacitors are plus or minus 20%, some are plus 80, minus 20%, so that certainly can have an effect on the formula and your timing. Also consider capacitance leakage. Electrolytic capacitors have more leakage than polyester or mylar, but polyester and mylar are hard to find in higher capacitance values. Also, it's good practice to minimize the capacitance value where you can and increase the resistor values up to a point to get the timing you need. Also, consider another chip, such as the CMOS version, TLC 555, or there's several other CMOS versions of the 555 timer. That makes the chip much less susceptible to leakage, and I found that you can use higher value capacitors, such as electrolytics, without too much problem. Also, the CMOS versions take a lot less power. So just something to keep in mind. Okay, we're going to discuss in the next video how to interface the 555 timer with counters. First of all, I wanted to mention that I'm going to be using the CMOS version of the 555 timer. And in fact, they make a double version in CMOS, the CMOS version, as well as the normal 555. So there's 2 timers in one package. And we're going to look at 2 different counters, the binary counter, which counts in a typical binary fashion, and a decade counter, which counts 1 channel or output for every pulse that's received. So that's about it for this video. Hope to see you in the next one. Thanks for watching, and please remember to like and subscribe.